Hello everyone. Well, I thought I did the whole thing on Zoom, but the recording has failed, so I don't know what happened. Okay, I don't have to think about why it happened or what happened, so I decided to just retape it. This time I'm going to post it on YouTube as usual. Okay, so number one, the final exam will be on my math lab, and however the scratch paper will be uploaded on Canvas on assignment. I want you to have an app on your phone, so you take a picture, so it can be many pictures, right? Okay, multiple pages, but you are going to make a single file. If you don't know how to do it, you can Google it. So either you download the app or a scanning app, whatever you need to do, I'm sure you should be able to find that. Okay? And in order to complete the exam, you have at least 48 hours. Okay? 48 hours. But the exam time can be like 150 minutes. I give a time limit, but you know, some people can do earlier than others, things like that. Okay. It will open Thursday morning. All right. Well, number one, yeah, there are 3 chapters. Yes, these are chapters 8, 9, and 10. First, chapter 8 is about sampling distribution. So in other words, in this case, for chapter 8, yeah, I listed those review problems chapter by chapter. So first 3 problems about chapter 8, sampling distribution. So in this case, we know the population data. So there are all rental cars, and have you rented a car? Well, when you go there, usually, okay, this is what you want, and then they said wait for a few minutes, and then they go and then clean up the car and regular do maintenance job. And the data shows that for the whole population of rental cars, the mean of the maintenance time is 25 minutes with a standard deviation of 9 minutes. So now we are going to have samples, but the first one is just n equals 1, so it doesn't mean much. Okay, it is like just one car picked out over there, and then what is the probability that maintenance time is less than 19 minutes. So this is the same as just what P is less than 19 minutes. X over X bar doesn't make any difference over here, correct? Okay, so you can do this with the calculator, so normal CDF, and as you see, if you graph it, it is going to be, yes, they already said in the problem that the data is normally distributed with the mean of this standard deviation and that. Okay, so this data is normally distributed, so we don't have any problem to discuss or verify. Okay, so here mean is 25 minutes, and you want to compute this less than 19 minutes, so coming over here. Therefore, when you use a calculator, normal CDF, the left end part is negative 10 to the 99. The upper number is 19. And over here, because n equals 1, 25, the sigma and the mu as before, same as before. Okay? Once you do that, so 25 minutes or 5 minutes, I'm sorry, here 5 minutes. Yeah. 5 minutes and 5 minutes. Okay, so when you do that, you can find the answer. So let's do normal CDF, scanned bar, second bars, normal CDF goes to lower is this, upper is 19, mu is 25, and the sigma is 5. Yes, that is 28.33%, or that 0.2833. That's the probability. Okay. The next one is this time you are going to have a sample of 10 cars, and what is the probability that the mean maintenance time will be less than 24 minutes. So this time is x bar, okay, sample of 10, and this is less than 24. So when you switch to sample of multiple cars like this, what do you have to do? Yes, you are thinking about sampling distribution. Yes, you can make many samples of 10 cars. In that case, what is going to change? This mu is going to be the same as before because this is normally distributed. So mu sub x bar is the same 25. So this time, the sampling, the distribution, the mean of the means. And sigma sub x bar is going to be sigma over square root of n, that is 5 over square root of 10. Okay. What is 5 over square root of 10? That is 1.58. So as you do this again, we are going to set normal CDF. And guess what? This is less than 24, so same as before. By the way, you can do e to the negative 99, e to the 99 power, doesn't matter. But in order to do e, you have to do second key, so why not do this? Okay, 24. This time, 25, the last number is not 5. The sigma has to be changing to 1.58. Okay, once you do that, the probability is 0.26. About 26%. Okay, now number 2. Number 2 is that, okay, this time balance on credit card accounts have a mean of balance on a credit card. The mu is $395 and the sigma is $189. Okay. Again, this is for the all credit cards. So that means what? Tens of millions of credit cards. Okay. So this is about population. And from here, we are going to take just simply what? 500. Pretty big still. N equals 500. Make a sample. And we are going to investigate the things that to find the probability that how this sampling distribution will take place. Okay. So when you do that, when you make a sample of 500, that means you can make many of them, okay? Many of them. So what are we going to do? First of all, let's think about the normal distribution. In the problem, they did not assume that the population has a normal distribution. But however, here is the sample size is 500. N is greater than or equal to 30. We can assume that the sampling distribution is normal. Okay? Sampling distribution is approximately normal. So, it indirectly says that. Okay? So from here, we are going to make a little adjustment. Yeah, when you have a sampling distribution, mu sub x bar is going to be same as mu, so 395. However, sigma sub x bar is going to be different, 189 over square root of 500, which is 8.45. Okay, so using these two numbers, and then we can compute. Okay, so A is, what is the probability that the sample mean is between 400 and then 410? So sample mean is 400 less than 410. Okay, of course you can put equal sign over here, doesn't matter. Okay, it doesn't change the probability at all. So what do you do? Well, Again, you are going to put on a calculator. So second verse, and then go to normal CDF. This time, lower number is 400, upper number is 410, and the mu is 395, and the sigma is 8.45. So that gives you 23.9%. 23.9%, or say 0.239. Okay. The next one is 395, 8.45. Okay. So next one is a probability that the sample mean is less than 390. Sample mean is less than 390. Okay? So what are you going to say? This is, again, normal CDF. Negative 10 to the 99, and 390, and 395, and 8.45. Yes. Okay. You set up, and then you are going to have 0.277. Okay. Approximately 27.7%. Anything about sampling distribution is that it's not about a single sample. So what that means is, well, this is about 2.277, so 277 accounts out of what? Out of 1,000 will result in the the mean of this account balance is less than 390. That's how you understand, okay? As long as all these sampling distributions, you understand that this is not a single case, okay? So we are going to look at those samples out of how many, okay? Be more than 405. Well, to be more than 405. So this time x bar is more than 405. So what is that? So this time normal CDF, low number is 405. Okay, it goes bigger and bigger, so that is 10 to the 99 is the upper number, and the same thing, 395, comma 8.45. Yes, that one will give you 11.8% or 0.118. Okay, so again, your understanding is that, well, you can say 118 accounts out of 1,000 will result in the mean value is less than greater than 405, or you may say roughly 12 out of 100. 12 out of 100 accounts will result in the mean value of this account balance is greater than $405. Okay. Number 3. All right. You hear from CDC every day, okay? Director of CDC, well, gives us a briefing. Well, they said 18.8% of school-aged children, 6 to 11 years old. This is a population, okay? And among those school-aged children, 18.8% they are overweight. So we do not investigate or we do not record their weight. What we do is compare to their height and the weight, and we determine this kid is overweight or not. Okay, so one way or another. So this is about proportion problem. It's not about mean of the weight. Okay, it's not that proportion. So this is proportion. P is 0.188. This is for the whole population. Now we are going to take a sample of 90 school-aged children. Okay, so from here, so this is a big population over here. Now we are going to take a sample of 90. Yeah, you can make many samples of 90 children. Okay, so what is the probability that at least 19% of them are overweight? So how we are going to say this one? So what is the probability that P hat this time? P hat is great at least 19%, so greater than 19%, 0.19. Understandable? Well, over here, in order to use this normal distribution, we must show that it has to be with this sampling distribution is going to be normal, because in the problem anywhere this proportion is okay. In the first place, there is normal distribution. It's not mentioned over here. So we are going to verify 3 things. First is that 1 n times p times 1 minus p is greater than or equal to 10. Okay? So what is that? What is p? P is this. So n, our n is 90. So 90 times p is this, 1.188. 1 minus p is 0.812. So once you multiply, you get 13.7, which is greater than or equal to 10. So first one is satisfied. The second one is that this sample is a simple random sample. Well, we are going to assume that, okay, this sample was randomly selected. Okay. The third one is, in order to guarantee the independence of this sample, meaning one child and another child investigated over here or surveyed over here, that it does not influence the other kids, the overweightness. Okay, so that is 90 is less than 5% of a population. What is a population over here? That is 6 to 11 years old school-aged children in the U.S. There are millions of them. So 5% of millions is greater than 90? Of course, yes. Okay. So why do we need this? So for example, if there are just compared to population, if the sample is so big, and then you may choose like some twins in the same family like that, if the sample is too big compared to the population. In that case, nowadays the scientists talk about that, so they have certain genes that are prone to gaining weight stuff. So they can be related. Those 2 kids have the same problem, okay, or same issues over here. So that's why, but this is less than 5%, not a problem. So these are all met. So we can say for normal distribution of these samplings, okay? Of sampling. So now we are free to use. So what is the probability that this p hat is greater than 0.19? Well, how we are going to do it? In order to convert, okay, so normal CDF, that's the same as before, normal CDF The lower number is 0.19, and the larger number is, upper number is 10 to the 99th power. Yes, the next one is going to be what is p hat you are going to put, okay? The proportion is the same. The sampling proportion is the same, 0.188. What about this? Standard deviation of these samplings, okay? That is by formula is 1 minus p over n. Okay? So square root of 0.188, 0.812 divided by 90. Yes. So once you compute that, that one is 0.0412. So you enter 0.188 and 0.0412. Once you enter this, it is going to be 0.4806. Did you recognize that this is going to be 48%, roughly 48%? Well, yes, because what the whole population has of this proportion is 0.188. We are investigating is what? 0.19. It's very close. Okay, and as you see in the normal distribution, right in the middle here is going to be, is going to be mu. So very close to 0.19. So this portion is very close to 0.5. In fact, that is 0.4806, roughly 48%. Okay. The next one, B. Suppose a random sample of 90 school-aged children result in 24 overweight children. What might you conclude? Okay, out of 90, but this time 24 of them are overweight. What is the probability of doing this? Okay, so this time the probability that p hat is greater than 24 over 90. We are calculating that. Okay, so same as before. Normal CDF 24 over 90, comma 10 to the 99, comma here 0.188, comma, what is that, 0.0412. That gives you 0.0281. Well, I can say this is slightly less than 3%, correct? Okay, slightly less than 3%. So we can say